Hey everybody, this is Siobhan, welcome back. This is actually being recorded as part of a live stream for the 2D tutorial, but what we want to talk about is how to use interfaces with GDScript. That's, I think, a sought after feature for a long time. And to talk a little bit about, how to implement interfaces, object-oriented programming interfaces is what I'm referring to. Let's talk a little bit about why we would want to use an interface. And so to do that, from the conclusion of the extended live Q&A video that I guess we'll post in the description, if you haven't seen that, go ahead and watch it. We're going to create some system where it would maybe make more sense to use an interface, and let's talk about it from there. So the situation that's very commonly, that you commonly run into, especially with the shoot 'em up, and I felt irresponsible leaving this beginner tutorial off at a point where you would naturally run into this next. I feel like it was kind of a cheat to not show you how to deal with this problem. So if I come back to the script, you'll see that every enemy, or let's go ahead and play so that you can see what's happening right now. So if I shoot and when the laser collides with an enemy, notice how it immediately destroys the enemy and you get score for doing so, right? It destroys the enemy instantaneously. And I know some of you who maybe want to actually make a shoot 'em up would realize that in what shoot 'em up do all enemies always get destroyed in one hit, right? They usually have health, right? And so if they have health, how do you implement a health system? And that is naturally going to lead you down the path to, okay, well, if there's a health system and you have different types of projectiles, lasers, missiles, other types of things, maybe the player can upgrade their lasers so that they do more damage. Well, how does the enemy know how much damage to take? So for example, let's say that we have health, right? And we had created this system in the live Q&A that we were just doing, where we have a health system, right? And we start with 10 health perhaps. And let's say that when the player, or when the enemy is hit, we don't immediately destroy the enemy. Right? We don't destroy the enemy immediately. We reduce its health, right? And we can do that by saying, health minus equals, and I don't know, let's just say 5. Let's just use some magic number for now. And so now what we can do is we can check, hey, is the health less than or equal to 0? And if so, then go ahead and destroy it. And these are comments from actually the beginner tutorial from before, kind of, disregard those. But basically what we're saying is we're going to reduce the health, and if the health is less than 0, then let's go ahead and destroy the enemy and let's increase the score, right? And so we have this health variable. It's a member variable. Each enemy has its own health, and they start with 10. So now when I go ahead and hit play, and I run this, and I shoot, then it destroys it. And I shoot, now it has 5 health, and I shoot, and then it destroys it. So now they each take 2 shots. All right, so very good. Well, you can see that while that works, and that's pretty cool, especially if you're a beginner, you're like, wow, there's a health system. All it took was that. Okay, cool. Hopefully this makes sense, this little health system that we've created. But the problem, of course, is, well, 5, that's a magic number. What is it? Do we set it up here? Do we say export var damage taken is 3? It's like, wait a minute, is it always going to be 3? How do what if we want to make it so that the projectile itself kind of dictates the amount of damage that is done to the enemy? And you see how this is a problem, okay? The problem with this is that who knows how much damage this enemy should take? The projectile knows, right? So the laser perhaps has its own value, right? And we say var, I don't know, damage amount or something like that. And let's say it's 5, right? So very cool. We'll say that, well, way to use a colon like a silly person. Damage amount is 5. Well, how do we then convey this damage amount to the enemy, right? Do we just say this is laser.damage amount, right? Well, you can see that's obviously a problem because, well, I guess we'd have to make this a static variable for it to see that. But how does it know it's getting hit by a laser? Now are we going to complicate it by saying is it a laser if health is less than equal, up here would say if laser, then do minus equals 5. If missile, then do minus equal 20. you can hopefully see how that's already really bad. It's like, well, hold on, what if there's an upgrade system where lasers are now 7? It's like, well, I guess we've changed the static variable. What if some of the lasers are 5, some of them are 7? It's like, oh gosh, because like there's a power up, right? It's like, well, now are we shooting like upgraded lasers, or is going to create a separate class for like upgraded lasers? You see how like you start to like think about these things, and it's okay to like wonder. It's okay to like, while you're trying to go to sleep or you're in the shower or whatever the heck you're doing, you're trying to think of like a better way to write your code. And those are things that just come to your mind. You might also think like, oh, I know, we should use signals because people say signals are good. Good, signals, yeah. Well, you can see the problem with using signals is this whole thing that we just did in the live Q&A. Again, watch that if you haven't already. If we do this, game over happened dot emit, it's like, oh, okay, under the player, like we can pass in a number, right? So we can create a signal called like laser hit enemy or something like that. And then what? Put that in the game state. It's like, okay, well, maybe we'd put it somewhere else. It doesn't matter where you put it. The problem is that that signal is going to be connected to all enemies, right? Laser has hit enemy or whatever it is. We're going to just fire that signal from the laser, perhaps, let's say. Yeah, like this, like is in group enemy. Let's do Q free. And are we going to just like emit that signal from here? Well, what? All of the enemies are going to get it. You know what I mean? Because all the enemies are subscribed to it. So it's like, are they all then going to take damage? How do you make sure that it's only taking the damage of that particular enemy? Oh, well, I could pass in the other area so that it can check to see if it's itself. At this point, if that even makes sense to you, then good job. You're, you know, pretty good. You're advanced to a certain level, but don't do that. You can see how it really starts to get icky when you do all that. So you don't do that. Instead, what you would do is use interfaces, perhaps. But guess what? We don't have interfaces. And before we talk about how interfaces work, let's talk about what you can do here right now with GDScript out of the box. So right now we have health minus equals, and effectively we want to say the laser here. So instead of this on area entered, let's make it so that we're going to create a function inside of the enemy, and we're going to say take damage, let's say. And amount will be like the amount of damage that it's taking. And then we'll do this junk. We're going to put it in here, and I'm actually going to comment out this stuff. And we'll just comment out all of this stuff and just put in a pass. It's like he's reading my journal of learning all of this the hard way. Yeah. Very good. So, right, we're going to do this take damage function, right? And so under laser, we can say, hey, guess what? If the, is in group enemy, then let's queue free, right? Because if we did it here, if we said like other area dot take damage and then pass in the damage amount. Remember, self.damage amount, because this refers to this variable that belongs to the laser because it knows how much damage it does. Then we're going to say, take damage self.damage amount. If we do this, what we see the problem with it is as soon as I shoot, it'll be like crash, wait a minute, take damage doesn't belong to player.gd. Remember, as soon as you fire the laser, it's going to collide with the player's collision shape, and so it's going to crash. It's going to crash the code because the player doesn't have a take damage function. Only the enemy has a take damage function. So I guess we can come back in here and be like, oh, well, duh, we wouldn't put it here. You would put it here inside of the enemy, other area.take damage. And so now when we hit play and we shoot, it doesn't destroy the player. And guess what? Look, it works. We're able to do that. It's like, oh, that's cool. And very good. A couple problems with this. One of the problems is we are now making assumptions about a couple things. First of all, remember how the enemy can take care of itself? Well, now the laser is taking care of the enemy, right? So that's kind of a problem. Second of all, we're making assumptions that enemy always has a take damage function. Maybe it doesn't, right? So how about, okay. Instead of saying the enemy's take damage function, because maybe it's not just the enemy that takes damage. Maybe there's like power-ups you have to shoot and like it blasts their shield. Like maybe the power-ups have like a shield, so you have to destroy the shield in order to be able to get the power-up. Or maybe there's like, NPCs that take damage also that are not enemies, or like, environmental things like a tree. Who knows? Like maybe they take damage too. Like asteroids, those aren't enemies and they take damage. So what we can do is we can ask this question. We can say other area dot has method Now, method is just a member function. It's a function that belongs to an object. In other areas, the object, we're going to ask the question, hey, does this object, this other area, have a method called take damage? And if it does, we'll then call the take damage function. This cannot crash ever. This might crash. This can't crash. Why? Because we just checked if it has a take damage function. So if it does, we can call it. Now, it might crash if like we change the number of arguments that take damage expects and stuff, but you know what? That you can fix that if you really wanted to, but it requires a little bit more effort. So now when I hit play, you can see that, well, the player doesn't have a take damage function, so it's not getting just, you know, wrecked anymore. But these enemies do, and so they're able to take damage. And so this right now is currently, to my knowledge, kind of like the way that you have to deal with interfaces, right? You have to like ask that question. Does it have a take damage function? Well, you can see the problem with this is because, yeah, there might be things that take damage that don't take damage from lasers, perhaps, right? Like maybe a tree or maybe the player, we add a take damage function, you know, or something like that. And suddenly it makes things messed up. The other problem with this is what if we change the name? Like what if later on enemy is like, it's not called take damage, we call it's like, well, take damage amount. I think people are getting confused. And as soon as you do this, the problem with this is not only does this break, it breaks in a way that it doesn't tell you that it's broken. The game just doesn't behave correctly anymore. You see how that's a problem? When it breaks, you want it to break spectacularly, especially in the debugging situation. You want this to break in a way that like it crashes the game and tells you why it's broken so that you can quickly fix it. And you might be like, well, I'm not going to break it. I'm just going to keep it called take damage whenever I want. Famous last words when you say that kind of thing. As soon as you have 100 scripts and you accidentally like merged your files in some weird way, or you accidentally put, you know, you've misplaced something, or you accidentally like put a tab here, now it's like a sub function or something weird. Yeah, call me back and say like, okay, I blew it. I don't know why it's broken. And what if like now 100 different things take damage? It's like, how do you update that? It's just gonna be, it's such a squirrely mess. And this is what we call, for those people who are in the know, this here, where is it, laser? This here is called a string reference, a string reference. A string reference, you can't autofill it, right? I mean, to some extent you can, like with the I think some things like string reference autofill, like the is action just pressed, but like what, you have to spell it exactly right, right? And if anything changes, it breaks, and this is not inherently an error because it's not referring to anything. It's just a magical string, right? It's a literal string value. It's not attached to anything. It's just being used as a key to find a method. So you can see how this is potentially a problem. So how can we maybe make this better? That's kind of what I want to get to. Now you can use this because that's what like tons of people do. They use exactly this in order to handle this problem of being able to decouple this idea of enemies and damage. And if you want to be able to create some category, what are you going to create? A group called takes damage? Like you could do that. You can say like, is other area in a group called take damage? Well, what if the idea of something that takes damage is more complex than just it has a particular method, right? You could have a whole group for it, but then that still doesn't create a guarantee that it's going to break the code, right? If like, you know, it doesn't follow this whole, like it has that method. Just because it's part of a group called it takes damage doesn't mean it has a method necessarily. You have to write that in spurious, kind of hard to track logic throughout your code. So what if we wanted to put this in like one place? Because back in the day, let's say, back in the day, with object-oriented programming principles, we have this thing called interfaces. Okay, an interface allows you to basically say, hey, this object belongs to a particular class, right? Like the enemy class, right? It takes stuff from the node 2D class, but it can only be one class. You can't say class enemy and also like damageable object or something like that. Like you can't do that. It's going to be like, what the heck are you doing? Because something can only be one thing, right? So what if I wanted the enemy to be able to be something that is damageable, but it also is something that is, you know, has score or whatever it is. Interfaces allow you to specify some characteristic about this class, this object, that guarantees that it has a particular set of methods and variables. And that's what we call an interface. All right. So if we wanted to do that, let's go ahead and we can define interfaces. Let's create an auto load. So under project settings, I'm going to create a new thing called interface. Okay. And I'm going to add it, and I'm going to create a script called interfaces.gd. I'm going to go ahead and click create. Very cool. And I'm going to open this up. Again, what I've done is I went to autoload, tab, I created a new script called interface.gd. I made the object called interface capital letter because classes have that capital letter, Pascal case is what it's called. Like capitalized camel case. And I'm going to open that interface.gd script. So here it is, interface.gd. I'm going to get rid of this stuff because all this does is it's handling interfaces. So if we were using another programming language like C# or something like that, we could just say something like interface, right? I'm not going to get into the exact syntax of C#. So we'll just make it basically like pseudocode. We would be able to say like interface, and we could create a thing called Damageable, right? Except you would typically not like all caps it like that. You say like interface damageable, and then you would specify what are the terms of being damageable, right? So this is like what people say a contract. You know, like when you sign a contract, you're saying like, okay, I'm going to come into work at 8:30 in the morning every day, or else like I've like failed my job responsibilities, and you know, all that kind of stuff. You have a contract. It says if you do this, then you get paid this, right? Similar kind of idea where an interface says like, okay, it has these methods, right? Has these methods, right? And it would be something like take damage is one of those functions, right? And it has like these properties, like, you know. So basically this is how an interface works. And whenever anything, what we call implements damageable, so for example, under enemy, we're going to say, hey, it implements damageable. What that would then say is that this function or this code will crash if it doesn't follow the rules. It doesn't actually have a take damage function, and it will tell you, it'll say it's done, it crashes. And by doing so, by it committing to follow the rules of what damageable means, then you can make assumptions about it in things like laser, like, hey, if it implements take damageable, then we know it has a take damage function. We also know that it has this function, and it has this variable, and it has these things. Doesn't that sound a little bit better? And it crashes if it doesn't work, right? Instead of, hey, it doesn't work, and for some reason it's just not doing it. It just doesn't work. It doesn't crash the game. It just doesn't work. So that's what we're trying to do here with GDScript. So how do we do that? So I'm going to go ahead and come back here to interface, and I'm going to go ahead, and hopefully you're following along, because this is where it gets a little bit tricky, perhaps. Let's go ahead and create inside of this interface, let's create something called, let's create a class, and we're going to make it called Damageable. Okay, this is going to be a little bit tricky for a lot of you. So if you don't know what classes are, I'm not going to take the opportunity right now. This assumes you know some basic object-oriented programming principles, like what a class is. I've talked in the live Q&A about how to set a class name, but you can create a class. This is what's called a subclass. It's a class inside of this interface GD class. That's okay. So it's a subclass. That's fine. We can define a class within a class. That's totally legitimate, even inside of GDScript. And so inside of this class, we're going to say that it has the function called take damage. And so far, this is totally legit, right? And it has, you know, we're not going to worry about the actual parameters. We could if we wanted to, but let's say we don't have time. And just so that it doesn't crash, we're just going to say pass. Because this, we're not telling you how take damage works, because everything's take damage works differently, right? Maybe someone has a shield, maybe something catches on fire, whatever. So take damage works differently depending on who is implementing this damageable interface. Okay, so we're just going to say pass, and we're going to let each class that implements this damageable function figure out what this take damage method means to them. So here we go. We have this class. It's called Damageable. And then inside of enemy, we're going to implement that. Okay, we're just going to do it in an interesting way. We're just going to create a variable, and we're going to say implements, right? It's the same thing. It just has the word var in the beginning. And we're going to say an equal sign. So, okay, now we've got some equal signs and stuff. And we're going to say, yeah, Unfuzz like, what? GDScript has interfaces? It does now. So look, if you don't have any idea what I'm doing and it looks like I'm just a madman on fire, that's okay. Just you can follow along. You don't even have to understand what it's doing. And if you get it to work through how I'm doing it, I want to design this in such a way that you can use it without even understanding really entirely how it works. If you know how it works, great. But you know, like how it works, that we got it to work. As long as you understand how to use it, that's what I care about. Anyways, so implements equals, I don't know, let's go ahead and say the class. So interface, oh yeah, it's an auto load, right? Remember, this is an auto load, so it's a singleton. We can access it from anywhere. Interface dot, what do we want to call it? We want to call it interface dot damageable, right? We spell this correctly. Did I spell? Oh my gosh! I call it interface. I wrote interface, folks. No, must fix. It can't be called interface, for the sake of all things good. It must be called interface, and now we must come to the project settings and fix it immediately. Remove, retry. It should be called interface. My gosh, interface. Thank you. Is it spelled right this time? Oh my gosh. How did this let me do this? Okay, hopefully, is it gonna crash? Where is this? And float an operator. Have I crashed something else by doing this? Self-deposition.y. Oh, did I delete something? No, I didn't. Maybe it's because the export, it wanted it to be above. Hey! Thanks, GDScript, for being so particular about where I put my export annotation. All right, very good. It works. See, I love like making these mistakes in front of you. So very good. So implements equals interface damageable. Okay, so what I've done here, again, now that it's spelled correctly, hopefully fast forwarded through that. I have this global variable, basically, this global auto load interface, and it has a subclass it called Damageable. So when inside of enemy, what I've done is I've set a variable to the class itself. I haven't instantiated it, and I'm not planning on instantiating it here. So we're just like, it's just the class. Okay, and this is it. This is all you need to do to be able to use it. Okay, so now how does it actually work? So inside of laser, right now we say if other area has method take damage. Let's say, okay, that's neat, Control K. What I want to do instead is I want to ask if it implements that interface, right? So now what we can do is we can say if this implements variable is inside of other area. Okay, you use this in keyword here thing in order to check to see if this variable with this name is inside of other areas. So now if I hit save and I hit run, and we see ta-da, and then I shoot, and it destroys it. Look, see, because it has the variable implements, right? Well, of course you see that's not all that helpful. Like, you know, if I say implements z, then you'll see that it's broken. Okay, that's fine. Which is a problem that we're not really going to be able to fix, but that's okay. The bigger problem, though, is the interface doesn't even work, right? If I come to interface.gd and I, like, you know, call this take damages with a z, you'll see that it still works because all that we've asked of the object is that it has a variable named implement. And right, it also doesn't, I could implement something else other than damageable and this would still work. So we've got some work to do. Right? Yes, and so I don't know, definioxd, xyd says like, yeah, but we have a string reference again. Yes, so it's not perfect because it's not really built into GDScript. But the nice thing though is that we will always use implements, no matter which script is using the you know, interfaces. We're going to use implements, whether it be damageable or has, you know, shield or whatever the heck it is that, whatever interface that we are going to define, we're just going to make sure that we write implements, okay? And so therefore, there's only one string. We're not changing its name because we're assuming that like implements is just, the name of this particular string that we use for interfaces. Unfortunately, making it throw an error, though, would require a little bit more under the hood stuff that's just probably outside of what you would want to do until they officially implement interfaces into GDScript. All right, very cool. So let's go ahead and keep going. But what I want to do now is, well, actually, let's go a little bit further. Let's go a little bit further. So inside of laser, if it implements, let's make sure that it implements the correct thing, right? So what we can do is we can say if implements in this other area, and what we can also do is we can say if other area dot implements. Remember, we know this exists because we've checked to see it exists, and we're going to say if other area dot implements is equal to specifically the interface damageable, right? So now if I do this, and I go ahead and use the colon, very cool. Now when I hit play, and you can see that, hey, guess what? It still works, which is amazing. I love it. And if I wanted it to implement something else, like, so let's say we have implements, but we do make it called damageable Z, and of course, like, we have to fix it here too. No, why am I doing that? Let's like just actually make another interface. So we can just create another one called like class, I don't know, Playable, because it's like a game where we have different playable characters and stuff like that, and we do play. Something awful, gosh darn. Probably should have come up with a better idea. And for some reason, we want the enemy to implement that instead, right? It's playable. So now when we hit play and we hit run, it doesn't crash anything, but it doesn't do this anymore, right? Which is awesome, because even though we are checking to see if implements is another area, implements is there, but it doesn't implement specifically this particular interface, okay? It'll only work if the other area specifically implements this damageable interface, right? Now, if in an official implementation of this in GDScript, it would probably be something like, does other area implement this particular interface? But notice how you can use like autocomplete, and if anything changes, we call it something else, like takes damage, then this will crash because there is no, subclass called damageable anymore. So it does break now. See, if I called it damageable Z or something stupid, it will crash, right? There it is. It's like, what the heck is this? It doesn't exist anymore, right? So let's come back and let's call it damageable. And see, things are crashing. Good, right? That's how we want it to work. Okay, so we kind of have some system set up, but again, we haven't figured out this part yet. Right now, the enemy can have no function called take damage, right? If this was called take damage Z, even though the interface has said that it should be take damage without a Z, then notice how the code still works, right? It still works. We don't want it to work. Oh, it says non-existent function take. Well, yeah, it's because I was calling the function elsewhere. That's immaterial to this whole concept of interfaces. It died because it's elsewhere in the code was I referring to the enemy's take damage function. It didn't work anymore. Anyways, so I wanted to crash because it didn't follow the interface properly. Okay, so how are we going to be able to do that? All right, let's go ahead and let's create a function inside of interface, and we're going to make this function allowing us to check nodes. Alan says you could use something like has method. This feels like shoehorning static language features. Yes, and you probably came in a little bit later. That is exactly what we did do down here. I don't want to get sidetracked here. We already did the has, oh, sorry, it's under laser. Has method. All right, so coming back to interface, let's go ahead and do checkNode. We're going to check to see if it's, it can take any kind of node, because any kind of node can implement interfaces. So checkNode, we're going to check this node to see if it has these functions and properties and signals and all that kind of stuff. And so how are we going to be able to check this node? Well, first of all, let's make sure that this node actually has this implement variable in it, right? Because we want to check every node, right? If we want the interface system to work and to be robust, we want it to be able to check every darn node in the game. And so if it doesn't have implements, then you don't have to check it, right? Only check it if that word implements is in there. And then after we've done it, what we can do, and this is what's really kind of interesting, what we're going to do, and this is what's going to be kind of interesting, is let's go ahead and let's figure out what methods are part of this node. Okay, let's figure that out, right? So how do we figure out what methods are part of the node and what methods are part of this damageable class? That's how we have to do it. So what we're going to do is we know that the node that is coming in is trying to implement an interface because it has this word implements. Remember, this variable exists, right? Implements. As soon as it exists, we assume that what's coming to the right of it is an interface that's part of this autoload. In this case, damageable. So inside of interface, what we're going to do is we're going to instantiate that class that it's currently referring to. So what we can do is we're going to say var, I don't know, instance equals, and this is going to be the instance of the interface, right? So you can call it interface instance or something like that. I don't care. And I'm going to say node.implements. Remember, the variable is called implements. And we're going to create a new instance of this class. Remember, there's damageable and there's playable. Enemy happens to have interface.damageable. And so interface.damageable is what is being stored inside its implements. And because what's being stored is just this instanced class, we are able to instance it here by doing .new. And now instance has a copy of, in this case, damageable. So now what I want to do is I want to figure out, well, what is inside of this instance? And there is, let's go ahead and print. So I can print, and inside of the print, let's do like instance.get method list, right? Something like this. All right, instance.get method list. So if I print this and I hit play, you can see, oh gosh, it has, let's get rid of this. Where did I put this? These like numbers, I think it was under player. Please stop doing this. That was from the live thing. We need to do checkNode. So let's have the enemies check themselves as soon as they're spawned. So let's do interface.checkNode. And this is just for testing. We're just going to pass itself in. Okay, so I'm going to hit play. And now you're going to see, and I'm going to hit pause. And then I'm going to come back to the output. You can see that this is all the junk that's inside of any enemy that is spawned, right? Except it's not any enemy that's spawned. This is the stuff that's inside of, if you remember and you look carefully, not the enemy, because we're not doing node.get method list. We're getting the whatever the node's implement variable is, the instance of whatever class that implement variable is set to, which is this damageable. What the heck? What is all this stuff? I don't want all that stuff. Hint string, usage, hint, class name. Whoa. So here's what's kind of weird. So this little get method list gets like all the methods associated with any object, which is fine, but I want just the methods that the user defined in the source code. Okay, the source code meaning this particular script. So what we can do is get script method list, which is the methods that were defined in the script. Now if I hit play, non-existent function. Is that, oh man, I think, where does get the script method list? I'm pretty sure it exists under object. So if I were to do like self.get script method list, if anyone in the chat here knows what the actual name of this function, it says non-existent function, but I'm pretty sure it exists. Oh, it belongs to the script. Duh. This is like some kind of crazy wizardry. Does that work? It does. Very cool. Now when I look at this, it has this array and this thing right here, take damage. So this array, including this like object in it, it's the whole list, right? And it's the first item here, and it's a dictionary, and the name of the function here is this take damage thing. Okay. Whew. So if what I want to do is I want to get the name of the function, right? So, what is it called? Name? Oh gosh. So that is the method list here. And if we want to get the first item, which is 0, and then we do .name, and we hit run, take damage, take damage, take damage. Notice how it's always the first here. It's the only method in there. But in order to make this a little more clear, and this is where we're going to go, is what we're going to do is I'm going to get this script method list, just like we had done before, but to make this a little bit more clear, a little bit more easy to read, I'm going to iterate through it. So I'm going to say for each method in this instance, get method list. And I'm actually going to embiggen my code editor so you can see better. And let's print each method's name. Okay, now when I hit run, take damage, take damage, take damage. So you can see that there is only take damage because this for in loop, again, the for loop, not again, but for those of you who are familiar, this is a for loop where we go ahead and we loop through this particular array, this particular list. All right. And so each method inside of this method list, we're going to print its name, and you can see it's only take damage exists. Okay, very cool. So what we've done here is we're able to now know that this method name exists inside of Damageable. Now what I want to do is I want to make sure that every one of the functions that are inside of here, so for example, if I did another one called, it's Damageable, I don't know, take critical damage or something like that, which is not a very good thing to do, but let's say we did it and we did pass. You can see that when I hit play, you'll see that it has both take damage and take critical damage. Both of those are now functions that exist inside of this method list. So instead of printing it, what I want to do is I want to assert that it exists. So what I can do by asserting is I can assert that the method name here is inside of node, the node that we're checking. We're making sure that the method name that's part of this instance of whatever it is that we've instantiated, which is this Damageable class, which belongs to implements, we're going to make sure that its method, each method, again, for each method, you can find that method inside of the node that is supposed to be implementing this Damageable interface. So now by asserting that, what I can do is I can actually put in a comma here, and I can, well, let's just see if it crashes, right? So if I run this and it goes, hey, look, no crashing, and it works still. Very cool. Now let's test to make sure that this works by coming over to the enemy function, and I'm going to do take damage, except, I don't know, let's say that we didn't have this function anymore, right? We called take damage with a Z, like we always keep doing. It doesn't have the function anymore. It immediately crashes and it says assertion failed. What? It failed because it tried to, assert that, hey, this method is inside of this node and that assertion was wrong, so it will crash. That's what an assert does. It basically is like a throw error if this condition is false. Okay, that's what happened here. So now if I come back to enemy, and I'm going to come back to making it called take damages, this is really promising. It appears like it is working, right? But I want it to be more verbose because, like, okay, assertion failed. Assertion what? So what we can say is, I don't know, something like interface error node, and we'll just give the name of the node. Let's put a space here. Does not possess the, and it's too many. Let's just put this on a new line here. Does not possess the method.name method, right? Now, and you can use these little, you can create a new line like this, and that'll work. And keeping the plus here, the operator on the end of the line, makes it a little bit easier to read that that's what we've done here. So now if I go to hit run, and okay, it's working again because I renamed it back. But if I come back and I make it called take damages with a Z, so that I can crash it again, it says interface error, enemy does not possess the take damage method. Boom! It tells us exactly why it broke. It's because we, at some point, either accidentally, we weren't thinking, or someone broke it in our team or something like that. It will break and it'll immediately tell us how and why, because it doesn't have the take damage function anymore. You see how that's really, really, really cool? Hopefully that makes sense. Maybe it doesn't, but you can rewatch it if you want. I'm going to uncheck this little check node. I'm no longer going to have, because I don't want you to have to do this, right? I don't want you have to like manually say check node inside of the ready of every type of script, because I want this to work out of the box just because you did this, just because you did var implements equals interface damageable, and because you created this little class thing up here at the top. So I want it to automatically check the node whenever it spawns, right? And so to do that, inside of interface, what I'm going to do is on ready. And again, I might seem like kind of a madman, so like, again, pause it if you need to, or ask questions in the chat if you're still here. What I want to do is I want it to check every darn node when they're born. So what we can do is we're going to get the tree from our autoload script, and I want to, there's a signal here called node added. So if I look at it, it says it's emitted whenever a node is added to the scene tree. That looks perfect. So I'm going to come back to interface, and we're going to connect just like we had done before. Watch the live Q&A if you weren't part of this. And I'm going to connect what? checkNode to this. And this tree added thing, or node added thing, notice how it has a node. It'll pass a node automatically to the function that is connected to this signal. See, it'll pass in the node that was added. So very, very cool. So here we say check node, and I'm going to go ahead and play again. And notice how it's working, because I think I fixed it. I keep fixing it. Unfix it. Take damage with the Z. Okay, so I run here. Notice how this darn one is still working. Wait a minute. Not exact. Okay. It didn't work automatically, unfortunately. I was hoping that ready function. Oh, darn, I'm missing an underscore, guys. Come on, folks. Help me out here. I'm missing an underscore. What? All right, now I'm going to hit play. Okay, still it doesn't work, but now it works. As in, like, it works and then it doesn't work. What we wanted it to do is we wanted it to not work. It broke. I love your tutorials. Thank you. All right, so you see how it worked? It says that does not possess the take damage function. But do you see why it worked, though? We saw why it worked, but why didn't it work right away? Because this, see, like, every time an object is added to the tree, it's going to use this checkNode function on the node that was added to the tree. It's going to come in here. It's going to check to see, hey, does it implement? Does it have a variable called implement? If so, we're going to check to see, hey, if the thing that is implementing, is it going to, have the characteristic, have the methods of the class it was supposedly implementing, so to speak, the interface that it was implementing. It's kind of like faux interface that it's implementing. Well, if that was the case, then why didn't it crash instantly? Notice how there's an enemy right there. That enemy had the variable. That enemy had the implements variable. Why did it not work? Well, you can see the reason why it didn't work is because this signal will only emit once something has been added to the tree after this has run. When does it run? After this darn tree already exists, right? This tree is here already. This is not going to run until the game starts, and this tree already exists. We want this to run. We want to check every node that already exists, not just the ones that are born after everything has started. Now, if someone else has, again, this is like coming out of my own crazy mind, so if anyone else has like a better way to be able to check every node, this is just, me, let's say like, this is me writing a way to get every node. And also, if there's a better way to get every node, as far as I know, you can't get every node, right? You can do get children, right? So you can do something like, self.getChildren. Like you can get children, but that only gets the direct children. Like, it doesn't get all of the descendants too. And as far as I know, there isn't a function called like get all the darn descendants. Okay, so what if we created our own function called get all the darn descendants? Not literally, but let's create a function and let's call get all descendants. Is descendant spelled with an A or an E? I'm so bad at spelling that word. Is it an A or an E? It's a descendant, right? Someone tell me in the chat and we'll fix it if necessary. So it'll take in a node and this function is supposed to return all of the descendants, not just the children, all of the descendants. Well, here's the problem with getting all of something, because we know we're going to have to do this whole like get children thing, right? Because that's how you get children, and we want to get the children. Well, we could use like a nested for loop of some kind, but we don't know how many nestings we need to do. So what we're going to do is we're going to use something we're going to use what's called recursion. Okay, so here's how we get all the children, right? So we're going to say var, I don't know, children of this particular node equals get children, and we're going to loop through these children. We know that that's something we're going to do. Again, if you don't know where to start, just start with what you know. You know you're going to be getting children, and you know you're going to loop through them. So we're going to do so for child in children, right? So this is going to get every child in each children. Well, what are we going to do? Well, we're going to return the result of appending those children together. So we're going to do return calling this function get all descendants, and we're going to assume that this is going to return an array, and we're going to do append array, I believe is. In fact, if you don't know, I'm just going to go ahead and like come over here and I'm going to just try it out, right? So we're going to do like this dot append array. Yeah, so there it is. It allows you to like combine two arrays together. So append array, and we're not going to append array. We're going to return the result of appending the array to whatever we got from the get all descendants, which was an array. There we go. That's better. But what are we appending the array to, right? We're going to get an array from this, but we have to start with an array. So let's assume that we're just going to start with an array. So we're going to say var, I don't know, like array. Let's just say all descendants, because whatever. Ants equals, and let's start out with just this node inside of an array. And then after we're done with all this, let's not return it. Let's just append the array. So all descendants is equal to append this all descendants. Wait, is append array destructive? As in like, I think it is. So I think I don't have to like set. I think I can just do append array, and it'll like append directly to this array, I think. And we need to pass in a variable here, right? So we're going to pass the child in. And let's then return all the descendants. Okay, so hopefully this made sense. Actually, I don't know. If it didn't make any sense, that's totally fine. But if there's a different, better, or faster, or built-in way to be able to get all the descendants of something, then let me know. But again, what we're doing here is we're going to start with an array that has just the node in it, and then we're going to get all the children of this particular node, and then we're going to go ahead and we're going to call the get all descendants function that we are writing. We are inside of the get all descendants function. We're going to call the function in itself. And then for each child, it's going to start with this. Each child is going to be inside of its own lone array. And then each child's children are each going to be inside of their own lone array. And eventually, they're not going to have this loop because they're not going to have any children. And so ultimately, they're just going to be this. And once they end with this, that's basically what we call the tail. Each of them are just going to be this. And so what we're going to do is we're just going to return this, just empty thing. And it's going to bubble back up, and it's going to go ahead and append this to whatever you've gotten so far, and ultimately it should be just everything. Okay, so very good. Let's actually test to make sure this works. So let's go ahead and print the result of calling the get all descendants of the scene trees, current scene. So that's just going to be the main scene. It's just all the darn children of the main scene. So I'm going to go ahead and play. And cool. No, stop. Okay. Come back to output. Look, main, space background, player, ship graphic, collision shape, enemy spawner, timer, everything is there. And it's all inside of this array. So you know what I want to do? I want to, instead of just print, like getting all the descendants, I want to check everything. So I'm going to create a thing called var all the darn nodes. And okay, I'm too many things. So all the darn nodes, and I'm going to say for each node in all the darn nodes, let's go ahead and check the node. And we're going to pass node to that. So we're going to call node, check node at the very beginning on all the existing nodes that are at the beginning. So now I want to hit play. It's instantaneously going to crash because there was already an enemy right there at the beginning, right? If I look back at my scene tree, there's an enemy right there in the very beginning. And so instantaneously, it's going to crash because it got all the darn nodes and it looped through all of them, it checked all of them, and that darn enemy didn't have a take damage function because, again, it was expecting that it had a take damage function because it was going to loop through all of the functions that this damageable interface was expecting, and it was going to check inside of the node checkNode thing. It was going to create an instance of this class because the enemy is implementing this implements variable is getting this uninstantiated class interface damageable, and then in order to check, it's going to loop through all of the methods that are inside of this little faux interface, and it's going to check to see, it's going to make sure, hey, is that method inside? It's going to say, hey, that method is inside of the node that we're checking, and it wasn't there. So that assert is going to fail, and it's going to crash and give this specific error message. And it only works in the debug. Like if you were to export this to the App Store, it would still work if you actually exported this project. Assert just works inside of the little testing debug mode. So now if I come back down here and I change take damage back to how it's supposed to be spelled, now it doesn't crash and it works. Some of you are saying hey, you know what, isn't there a slightly better way to do it? Yeah, absolutely. What? I'm just doing this on the fly. Come on, folks. But look, plus we haven't done this for variables and signals and stuff like that, but you can do that yourself, right? I don't want to do that right here. But inside of your checkNode, what you can do is you can just come in here, copy and paste, and instead do GetScript. See if I did self GetScript dot get. Oh, come on. I'm going to go inside here so we can just look at the methods that exist inside of the script. Notice how there's get property list, right? We already did get method list. There's get method list. There's get property list. There's get signal list, right? So come on, use the gears. Someone post this on the internet, right? So you see how that works? I can now do a for loop to check all the variables, or sorry, all the properties, which are member variables, all of the signals and everything. So maybe it's not perfect. And hidden, sorry, I don't pronounce your name. Won't breadth first search be better than depth first search here? And this thing happening at the beginning of here is come on. If I have to resist the temptation to get into a debate about this right now. But basically what I'm going to say here is that there are better ways you can do this. Let's just say that. There's better ways you can do this. You can loop this better. But the way that I've implemented it here, assuming that this is even there's a, there might be a better way to get all the descendants and I just don't know about it. This is going to take a fraction, it's going to be a millisecond, you know what I mean? It's going to be incredibly fast in order to be able to get all the descendants inside of the tree as it exists. And as soon as it runs, you're no longer doing that anymore. You're only doing it on ready, and you're going to check the nodes through this connect whenever something is added to the tree. And this is using a built-in feature. So if that's not optimized, then that's not your problem. It's a Godot problem that is an engine feature. So is the given node limited to implement only one interface? Awesome. Thank you, diffnoxyd. Exactly. So not only did I not show you how to do the whole like property, like get properties and interfaces, and signals and stuff like that, which hopefully you can take from here, but I also make it, I've also currently made it so that it only works with this interface damageable. Well, guess what? You can make it so that it has, interface dot, what was the other one? Playable or something stupid. Right? You can make it so that it's an array. And then all you have to do in here to make that work is just change checkNode. So you're just checking to see if it's in here, and then check to see if implement is an array. And if it's an array, then loop through and check each of those faux interfaces. If it's not an array, then just check it as if it's a single interface. All you have to do is like update the checkNode, and everything still works. And boom, now you have it work with arrays or just single, right? And it just works right out of the box. For the sake of time, I'm not showing you how to do that because hopefully you can do it yourself. I trust one of you will go out there and actually do this. But here's the thing. If you just did it up to this point and you were just doing method lists and you weren't going to update it to the new thing, maybe I'll do a separate video or or maybe like I'll just post like a GitHub link if someone does do the solution, or I just do it later. I can just post maybe a GitHub link to it so that you can add it to your own project. But all you would need to do, even if you like have no idea like all this recursion junk that we've done and like the classes and all that kind of stuff, for someone who's just using this feature, who knows generally how implements works, all you have to actually do to get this to work, once you have this code in there, whether you wrote it or not, to be able to use the code, all you have to do is create any subclass you want inside of interface. This interface, you just add this as an autoload. You add whichever functions you want. And this is the contract. Whatever function or properties you put inside of that subclass is what any node that implements that interface is by contract required to implement, as in to define inside of their own function definition, right? And so all you have to know how to do is create this little class, and whatever the heck you say are things that need to be in there. And then how to be able, and then it'll crash your game if you implemented it and you didn't follow those rules. And so all then you have to do to implement the interface is just do this var implements equals interface dot whatever, right? And that's hopefully relatively easy enough to do. It's not that much more tricky than this whole has method thing. And then inside of where you're actually going to be using it, to be able to use it, all you have to do is you just do this little if implements in other area. Now, again, this is still a string, literal string. It's a string reference, but I think that's better than doing this like littering your code with has method and like all sorts of different string references that you could do. This, on the other hand, is always going to be exactly the same one, right? It's always going to be implements. So whenever you're using interfaces, it's always going to be implements. And so if you really wanted to, you could probably go in further and like make this a little bit more safe if you really wanted to. Again, I'm up for suggestions. I can think of something that would be easy for beginners right off the bat. So implements in other area, and then to check to see like which interface you're looking for, you just say, if that implement is equal to exactly the one that you're looking for, and this is auto-completable, and this does crash. Not only does it crash if it doesn't possess those methods, but it will crash if you somehow screw this up. If, let's say, you change the name of the interface later on down the road, it'll crash in all the checks too, right? And then it works like this. So again, if you're kind of a beginner and you generally know how to work with interfaces, then it's really, hopefully, not that difficult to be able to use them. And I think it's a little bit stronger than using has method all over the place, or has property, or whoa. This guarantees by contract that this other area possesses all of the features of this little subclass here. Very cool. Hopefully that worked. So is a given node limited to implement only one Oh, yeah, I answered that question. Okay, well, I think that's it. I said I was going to end in 1 hour. It's been 1 hour and 47 minutes, like usual. hour 47 minutes from the live Q&A, but from this particular segment where we talk just about implementing interfaces, maybe it's shorter. But thank you all for coming out today. Hopefully you learned something, and hopefully more of this kind of content will come out, just weird things that I'm trying that are advanced insights into using Godot and GDScript and things like that. So give me your feedback, say what you liked, say what you thought could be improved, like and subscribe. But otherwise, I guess good luck with all your projects, and wishing you peace.